Hello and welcome. So in this section we will be creating a Space Invaders game. So I went ahead and made a new 3D project in Unity. I called it Voxel Invaders. So even though these games are usually just played on the X and the Y axis, we will be using the 3D settings of Unity because we have some models made for you guys and things will just look better with 3D models. So let's go ahead and right click, import new asset. I will import the player ship game object, actually the object, the model, and also after that I need to import the PNG which has his color palette on it. So now if I import him, you can see he looks pretty big. I'm just going to scale him down. Okay, that's pretty nice. And then I will move him down. You can see he doesn't have any color, he's just white. So let's just drag the PNG and drop it onto him. Let me just zoom in. Okay, drop this PNG. Come on, man. Onto him, and there we go. Now he has color. So we'll make it so that he can move to the left, the right, and then up. Up and down. So on the Y and on the X. Okay, so I'm going to quickly go to the main camera and change the skybox because later we'll maybe add a background, but for now I just want a solid color. So the skybox just doesn't look good with this type of game. And now let's go ahead and create a new folder called scripts. And in this folder I will create a new C# script called player character. Let's open it up. So for movement, as usual, we need some kind of speed value. So let's say public float movement speed, and then let's movement speed, and let's create a new method called void movement. And then here we're going to have the checks for the button presses. So let's say if input.getKey is key code is A. So if we're moving to the left, I want to say transform.translate vector3 dot right times, since we're moving to the left, this is the vector3.right, and we want to multiply by minus movement speed since this is to the left. Okay, that's for moving to the left. Now let's say if the input.getKey is D, I want to transform translate. So this is to the right, so let's say dot right times movement speed, and I forgot we need to multiply this by time.delta time, so we have smoother movement. Let's add this up as well, just copy and paste it. And again, let's check for input.getKey key code W, so this is up, transform.translate vector3.up times movement speed times time.delta time. Oh, I didn't put a period here. And finally input.getKey key code.s, so this is for moving down, so let's say transform.translate and vector3.up again, but this time we want to multiply by minus movement speed since we're going in the opposite direction of up, and time.delta time. So let's save this, and now we can drop down our movement script, and in void update let's call movement each frame. So each frame we check if we're pressing any of these buttons, and if we are, we want to move our ship in some kind of direction. So let's now select our player ship and let's add our script. Set the movement speed to maybe 50. We'll have to test it out, so let's play. Whoa, and I think this is way too fast. Yes, way too fast. And let's set it to maybe 4. This is way too slow, so maybe 10. This is also pretty slow. Maybe 20. Okay, this is fine. You of course can set the speed to whatever you want. So let's stop the run mode and let's add a box collider since we're going to be needing that. And you can see that this isn't really a good box collider for this model. So let's go ahead and just increase the size here. Let's say 5. Actually that's maybe 15, and 15 on the Y and 15 on the Z. And let's just edit the collider and bring that up a bit. Like that. Okay. And of course on the bottom. There we go. That's pretty good. We'll need this collider when we collide with enemies or enemy bullets. Let's call this object player character. And now we can freely move around the scene. And we're going to add shooting in the next episode and enemies further down the line. And we'll also have upgrades, all the usual things that these games have. We'll also create boundaries so the player can't exit to the left or to the right or up. So we're just gonna make him stop moving. So thank you for watching. That's been it for this lecture, and I'll see you in the next one. Hello and welcome back. So last time we made our ship move around in the scene, but I don't like the fact that he can go off the screen, and I don't like the way the camera is set up. So what I'm going to do quickly is go to the main camera and change the projection from perspective to orthographic, and I'll just increase the size to maybe 9. And now if I run the game, you can see that the orthographic camera is much different than the perspective. And now we're going to be fixing the boundary so that he can't leave the scene. Okay, let's just increase the camera a little bit. The size of the camera. Okay, this is fine for now. Later we will be polishing the movement of the ship so it looks and feels much better. But for now I'm fine with how it is. So basically, currently our ship can leave the camera, the, let's say, map, whatever, boundaries, and also the enemies, they would also be able to leave the ship. So what I'm thinking is we should create a new class that's going to disable these ships and then the enemy ships and the player to leave the boundaries. So let's go ahead and create a new C# script called map limits, and let's open it up. Let's reload all. And this script, this class won't be a mono behavior. I'm just going to delete this. So it's going to be a normal class, which we'll be just referencing in our player character scripts and in our enemy AI scripts. But for now, what I want this class to have is, let's say, public int minimum x, public int maximum x, public int minimum y, and public int maximum y. Okay, we don't need any of these methods. We just need these variables here from the class. We want to use them in our player script and in any other script that we want. So let's close this. And now in our player script we can say public map limits. You can see we can create a variable of type map limits, and let's call this limits and save that. And now if we go back to our player, we don't actually have any way to set up these limits. Even if I try to add the map limit script to the inspector tab, it will just say that I can't because it's not a mono behavior. Now to do that, we need to be able to change these values from our script in the inspector tab. We need to go back to our map limits class and say, oops, system.serializable, so that Unity knows that this class is serializable, so that we want to change these values in the inspector. So let's go ahead and save this now. Now back in our player character, you can see now we have these limits here, and I can click on this drop down and we have the minimum x, the maximum x, the minimum y, and the maximum y. Now we can call this script in any other class and we will instantly get these limits, which is really convenient. So let's go ahead and move our character to the left, and let's see. So this is position -18 on the x. So let's get out of play mode and say in minimum x -18. Okay, let's see the maximum x. The maximum x is 18. Let's check the minimum y. So the minimum y is -10. And let's now check the maximum y. The maximum y is 10. Let's set it to 10. Okay. Now let's go ahead in our script. Now we actually have to put in some code that will limit this movement. So let's go to our player character script, and in the update method we can just say transform.position equals new vector3, and in here we will make sure to, so each frame we will check its position, and we will make sure that the position is inside of these limits, so he'll never be able to go outside of these limits. So for the x here I will say math.mathf. This is just the library of a ton of math functions, and I want to use the clamp function. So let's open up the brackets, and this method here takes in a value, and then it takes a minimum and maximum value. So first it wants our position, our current position on the x-axis, and then it needs to compare this position with something. So let's say we want to compare it with the minimum x of limits and the maximum x of limits. So let's say limits dot minimum x, and then limits dot maximum x. So I'm just going to go to the next line because this line of code will be really long, so I just skip to the next line, and let's in here, so this is the y, so let's go ahead and say math.mathf.clamp transform.position.y, and we want limits dot minimum y and limits dot maximum y. Okay, and then for the z-axis we'll just say 0 0. Okay, let's go ahead and save this. Let's go back into Unity and let's now run our game, and you can see I can't move out of the bounds. The ship just stops moving. And the way this is set up, what's really convenient is we can, even if we increase the camera size, we can always increase these values, and we can always add them to different ships, to enemy ships, bosses, and it will just work perfectly fine. So that's been it for this lecture. Thank you for watching, and I'll see you in the next one. Hello and welcome back. So last time we made the map limits so that our ship or enemy ships couldn't go outside the map, and in this lecture we will be developing shooting. So let's go ahead and create a new folder called models, and in this folder I will import a new asset, and I'll just go ahead and let me just find my Space Invader voxel, enemies, friendly bullet .obj, and let me import the friendly bullet PNG. Okay, now if we drop this bullet into the scene, it's gigantic. We don't want that. We want it to be scale down. This is also pretty big. Let's just position it to 0, 0, 0. Okay. This is actually pretty nice. So the player will be shooting these bullets. So on the bullet now, let's go ahead and add a box collider. Let's just make sure that the collider is set up properly. Okay, the size is good. The position on the Z, let's move that. Okay, like that. And let's increase the size on the Y. And let's now just move it on the Y axis, and that should be pretty good. Okay. I think that's good enough. And now you can see here we have these tags, and currently this object is untagged. Let's go ahead and click on this and add a new tag. I will call this tag friendly bullet. And let's go back to our game object and set the tag to be friendly bullet. We'll be using this to check if this bullet hit any enemies. If it didn't, if it did, we want to destroy those enemies. We need these tags because if each bullet was tagged the same, then we'd have enemies killing each other, and that will make the game very easy. And we don't want that. And let's just add a rigid body and disable the gravity. And I believe that's it for now. Let's go ahead and create a prefabs folder. Open that folder and drag this bullet down into the prefabs folder. And now we have a prefab of this bullet called tagged friendly bullet, and has a box collider and a trigger. And I can now remove the friendly bullet from the scene. But I'm going to create now a cube. Okay, and I want to position it here above the ship, like this. Let me just resize it. Okay. Okay, good. I will call this cube shoot position 1. And now I will actually copy it and paste it to the left, and copy and paste it to the right. Shoot position left, I will call the left one, and the right one I will call shoot position right. Let's now select all of these and drag them into the player. And now they are the children of the player, and if we move our ship, you will see these cubes are moving with us. So that's where we'll be spawning our bullets from, but we don't want these positions to be visible. So let's just remove the mesh filter from these objects. There we go. And we also want to remove the box colliders. We don't want this to collide with anything. Okay, let's now go ahead and open the player script. And in here I will say public game object bullet. This is where we will be putting our bullet in. And now we need references to our shooting positions. So let's go ahead and create a public transform. Position 1, I will call the first one. Position L as in left, and position right as in position right. Let's save this and go back now into Unity. Select our character. Now we have the bullet game object. Let's drag and drop our prefab into this spot. And now let's get the shooting position 1 and put it in position 1. Position left, put it in position left, and position right, put it in position right. Oops. Now I want to, first off, when the game starts, you'll be able to shoot from the center, so when you have no power-ups. But as soon as you pick up a power-up, you'll be able to shoot from the left and the right one at the same time. And then when you pick up another power-up, you'll be able to shoot from all three at the same time. So let's go ahead and say, create a integer called power. And when the game starts, I will create a void start method and set the power to be equal to 1. And now in our movement method, actually let's get a new method for shooting, call it void shooting. So let's get the if input dot get key down. So when we press a key, and I want this to be key code space, so when I press space I want to shoot. And now we want to check if, actually let's do a switch statement. Let's say switch, and we switch on power. Case 1, we want to do the following. Let's just break this. So each switch, we spoke about the switch statement. After each case we need to break. Let me just get a default case going on. And break. Okay, so case 1, when your power is 1, I want to shoot from the center. So it's going to be game object new bullet equals instantiate, and I believe it's called, okay, position. We want to instantiate the bullet at position 1 dot position, and let's just get the normal rotation. And now that we have created the bullet, we want to add some kind of force. So let's say new bullet dot get component. We want to get the rigid body component, and let's add a velocity to be a new vector tree, and let's get a public float shot power in here. So now when we shoot, we want this to be moving up, so that's on the x-axis. So let's go ahead and say shot power, actually vector tree dot up times shot power. Okay, that's for case 1. Case power 2. Now this time we will be creating 2 bullets. So game object bullet 1 equals instantiate, and we instantiate the bullet on the position left dot position, and transform dot rotation, the standard rotation. And now we get, let me just zoom out so you can see better. Now we need to get the bullet 1 rigid body, so get component rigid body. Let's set its velocity to be equal to vector tree dot up times shot power. And let's go ahead and create the bullet 2. Instantiate the bullet on position r dot position, and transform dot position. Transform dot rotation. And bullet 2 get component, grab the rigid body, set the velocity to be equal to vector 3 dot up times shot power. Okay, so that's in case we have power of 2. Let's go ahead and now set it to power of 3. So game object, now we want to create 3 bullets, so we can just copy this code here. Okay, and let's just add a third bullet. This is going to be on the, how did we call it? Let me just check. Position 1 dot position. So position 1 dot position, and transform dot rotation. Bullet 3 get component rigid body, set the velocity of the rigid body to be equal to vector 3 dot up times shot power. And now for the default case, what we want to do is just copy the case 1 statement. Okay. I forgot to break after case 3. There we go. Okay, so this is our shooting method. We can drop it down and call it in the update method right after movement. Okay, let's go back into Unity, and now we should have a shot power. Let's set it to maybe 50. And if I move around, if I press space, you can see I'm shooting this bullet. And I like the movement speed of the bullet. You can see I'm shooting the bullet. And if I was to increase the power to maybe 2 in the script and go back into Unity, now you can see I'm shooting 2 bullets, and if I were to set the power to 3, I would be shooting 3 bullets. Oops, let me just restart the game. You can see I'm shooting 3 bullets, but we don't want 3 bullets, we want 1, and later through power-ups we'll be getting more bullets and more, well, shooting power. Okay, so that's been it for this lecture. We'll continue in the next one. Thank you for watching and see you then. Hello and welcome back. So last time we made shooting. Well, we have some problems with this shooting, mainly if I disable maximize and play and run now. You can see if I'm shooting these bullets, they just spawn and they never get removed. So they basically travel infinitely, and that's not good for our game because the CPU will be calculating these objects, so it's a waste of resources. So we'll be fixing that, and we'll be also adding some music, mainly a shot sound effect. So when we shoot, it plays a sound. So I went ahead and made a folder called sound, and I will import a new asset here. And I'll just navigate and get the shot sound and import it into Unity. Now if I play this, you can see we made the sound for you guys for shooting. I think it's good enough, but of course you can make your own if you like. So let's click on the player character and add component, add a audio source. Audio sources are, well, sources of audio. Basically we can play this, just disable play on awake, and we have a lot of these parameters here that we can change later, but for now I'll just leave them like this. And I'm going to open up my script, and on the player character I'll get a reference to the audio listener. So I'll say audio source, and I'll call this maybe audio S. And when the game starts, I'll say audio S equals get component audio source. And now if we go to shooting, whenever we shoot, we want to simply say audio S dot play one shot. Just play one shot. Play one shot, and here we can say the audio clip, which is the shot sound. And we can do it like that. We need to specify the audio clip as well. So let's say public audio clip, and call it shot sound. And now copy this shot sound here and just paste it inside of the play one shot here. And now go back into Unity. On our player character, we will now have a shot sound. Just drag our sound into that, and if I run now, you can see if I shoot, we hear the sound effect. And now let's go ahead and fix these infinitely spawning bullets. Let's go ahead and create a script. I will call this script def timer. And let's just create a public float called timer. And in the update method we can say timer minus equal time.delta time. And if timer is less than or equal to 0, I want to destroy game object. Okay, let's save the script and go back into Unity. Now let's go to our prefabs and find our friendly bullet. Let's add a component and add the script we just made, so def timer. And if I just reload this script, you can see now we'll have a timer here, and if I say 2 seconds, we can put this script on basically any object and it will instantly behave as a timer. Now if I run the game, and if I shoot, you will see these bullets will disappear after 2 seconds. Okay, but I also want the bullets I want to create a particle effect before the bullets explode, so we have a better feel. Let's go ahead and create a particle system. Let me just position properly. Okay. So I want this the emission not to be rate over time, but rather in bursts. So I want, let's say, a minimum of 40 particles and a maximum of 100 particles. I want the shape to be a sphere. I want randomized direction to be true. And I want the simulation speed to be much faster, so maybe 4. And the start size will be much smaller, like that. And let's just set the color to something like red. Okay, this size is maybe too small, let's say 0.3. Okay. And now we can make a prefab out of this particle system. I will call it friendly particle, and I will drop it down here. Just be sure to disable looping, because we don't want our particle system to be looping. And let's now go to our to scripts and get our def timer. Now let's create a reference to public game object particle. And before we destroy the game object, I want to instantiate particle at transform.position with transform.rotation. So now if I go to prefabs and select my friendly bullet, now we have a particle parameter here. Let's just drop our friendly particle in there. And now if I run the game, you can see we're creating the particles, but we don't actually see them yet. So let's go set the timer on the bullet to maybe 0.5 and maximize on play the game. Now we still can see it. Oh, we see the particles now. Okay, that's much better. But we again have a problem with these particles, the same problem we had with the bullets. So if I just continue shooting, you'll see that we have a lot of these friendly particles and they're just standing there doing nothing. But we can fix that easily. We already made a script called def timer. So let's go ahead and on the particles, add a component called def timer, our script, and set the timer to maybe 3 seconds. But here's something weird. This is asking for a particle. Now it wouldn't make sense to destroy the particle and then create it again. So to fix that easily, let's go ahead and in our script, right before we create the particle, let's check if the particle exists. So what this does is basically if particle exists, so if we dropped anything into this here, it's going to execute this code. So if we did drop a particle on the bullet, it will create the particle and then destroy the object. But if there isn't a particle, it will just skip this line and then destroy the game object. So let's go ahead and save this, and now back into Unity. You should see now everything will be working properly. You can see there it's exploding. And if I just wait now, you can see we are cleaning up our hierarchy. So we're saving on performances. Now the game is feeling really good. It's getting somewhere. So in the next episode we'll be adding enemies and we'll be killing them. So that's going to be a lot of fun. Thank you for watching, and I'll see you then. Hello and welcome back. So last time we added some shooting and sound effects, particles, and we added a timer to destroy our objects after a few seconds. Today I want to add power-ups. A power up and a power down that when you pick up, it's either going to allow you to shoot twice or 3 times depending on how many power ups you have, and a power down that's going to decrease your power. So let's go to the models folder and right click import new asset, and I'm going to import the power up object, and then I'm going to import the power up PNG. I'm just going to drag the object into my scene. I'll make sure to rotate it on the X by 90 degrees. Then I'll just scale it down. Okay, this is maybe too little. Let's say 0.4 I believe is good. Okay, let's now add the PNG onto him so it has color. So I want this object to be when collided with by the player, I want it to increase his power. So we need to add a rigid body to this object, and of course disable use gravity, and let's go ahead and add a box collider. Now of course we need to set it up properly. Go ahead and click edit colliders. Let's just set this up. Okay. There we go. Okay, be sure to enable is trigger because we will be triggering some events when the player enters this collider. And also we need to add a new tag. Let's call this power up and give this tag to this game object. And now let's go to the prefabs folder and drag this game object down. So we create a prefab out of this one. Just be sure to delete the game object from the hierarchy. And let's now import the power down object and the power down PNG. There we go. Let's just rotate it. And let's get the color in there. Scale it down. Okay. And of course, let's add a rigid body, disable the gravity, and add a box collider. Make sure that is trigger is enabled, and let's go ahead and edit the colliders. Okay. There we go. And let's again add a tag for the power down because we'll need it to check what we're colliding with. Power down. Let's give it that tag. And let's create a prefab out of this object. And now we can delete it from the hierarchy. So let's now go ahead and open up our player script, and let's create a method to check if we collide with something, and if we do, we want to increase our power. So I'm going to say void on trigger enter collider, and this is just a variable that holds all information from the object that we collided with. So we can say if that object's tag is power up. Now we want to check if our power is less than 3. If it is, we want to increase our power. Because how our game is set up, we can only have maximum of 3 power. If we had 4, we couldn't be able to shoot because our shooting method has only cases for 1, 2, and 3. So we have to make sure that it's always either one of those 3. Let's now make a check for power down. Power down. And again, we need to check if the power is greater than 1. We want to decrease it. So power minus minus. We don't want this to ever go below 1 or above 3. Actually, power greater than 1. So if power is greater than 1, we can decrease it. But if it isn't, we're just going to ignore this. So let's save this script and go back to Unity. And I can now add my power ups and power downs. Oops, this is the particle, sorry. Let's add the power up. Let's just position it like that. Let's add some power ups as well. Just make sure that the Z is 0. That's where the player is, also on the 0. Because you might set Z to be 10, but because it's in the camera is orthographic mode, you will still see the object without depth. So let's set it to 0. Let's add another power up and set this to 0 as well. And let's add some power downs now. Whoops. So now if I run the game, I should be able to... I can now shoot. You see I collided with that one and it gave me more power. Now I have 3, but I can't get more. And if I hit the red one, it decreases my power. But here's the problem, the power-ups stay in the game. We don't want that, so let's go ahead and open up our script. And then here, after we increase the power, we can just say destroy collision.gameObject, and do that as well for the other one. Just save this and open up Unity again, play. Now you can see I shoot 1, I close this one, it's disabled, it's destroyed. I now shoot 2, and if I pick that one, I shoot 3, and now if I pick the 4th one, I still shoot 3. Pick this one up, the power down, I shoot 2, and finally I shoot only 1. So there we go. That's how we make power-ups. Later, when we implement enemies, we're going to make it so that the enemies have a chance to spawn either a power-up or a power-down. So that'll be it for this lecture. Thank you for watching, and I'll see you in the next one. Hello and welcome back. So last time we created these power-ups, and when I pick one of these, I get to shoot more bullets. But if I pick a power-down, my power-up increases, and I go from shooting 3 to 2 and then to 1 bullet at a time. I'm going to go ahead and delete these power-ups from the scene, because we're going to set it up to have enemies drop them when we kill them. They're going to have a chance of dropping these power-ups. So go ahead and actually let's add some enemies. So I'm going to go to the models folder and add a new folder called enemies, and then here I will just get my enemies and import them. So I'm going to get the enemy bullet, and these, we have 3 of these models, so I'm just going to drag them into Unity. You can download them from Udemy, and be sure to do so. We made them for you guys. So I'm going to drag the first one up here, and you can see he is pretty big, so let's rotate him and then just scale him down. Okay, that scale is too big, let's say 0.1. Okay, and let's add the PNG to him so he has some color. Actually, there we go. Then let's get the second one up there, and let's again rotate him on the X by -90, and then just scale him down and get his color. Oops, I forgot to import his color. Just give me a moment here. Invader 2.png. There we go. They're the same, just a different color. And then we have the third one. Okay, I'm just going to move him there and give him his own color. There we go. So we have 3 of these enemies, and what we're going to do is we're going to create a script that's going to be randomly moving them at different speeds, and it's going to randomly spawn them. So this is going to be a kind of infinite game. It won't ever end until you die. So you're going to get score, and when you die, it's going to be game over. So let's go ahead, and now that we've got our 3 invaders, we need to set up some rigid bodies and other components. So let's go ahead and select the first one and add a box collider. Now be sure to edit the box collider because it isn't set up properly. Let's go ahead and just edit it real quick. Okay, that's good. I'm going to add a box collider to this one. Let's see if we can actually copy the component from the first one onto the second one. And we can copy the component values and then just paste them on the second invader, and it will work perfectly because they're the same model. Let's now click the third one, add a box collider, and as well paste the component values. Okay, we can increase the size a bit here. Okay, now let's go ahead and add rigid bodies to all of these, and be sure to disable use gravity and constrain the rotation because we don't want them to rotate when something hits them. Okay, There we go. Now that they're done, I'm going to go to the prefabs folder and create a folder called, actually no need, I'm just going to create prefabs out of these guys. Since everything is set up, we can now create a prefab from the first invader, then the second one, and then the third one. And I can delete them from the scene, and now we can spawn them from different scripts. Let's go ahead and create a new script called enemy controller. Let's open it up. So to move around, our guy is going to need some speed. Let's say public float speed. And I also want a timer for a change in direction. So let's say public float change timer. So every so often we're going to change the direction in which we're moving. So we're going to have them move to the left, then to the right, and in that fashion. Okay, so let's go back here. Just reload this script. Okay, and now actually we can go ahead and add this component we just made, enemy controller, to all of our enemies. And you can see that we now have these values here, speed and change timer. And how we're going to have it is basically they'll be coming from up, and they will be moving to the left and then to the right. But we'll continue with that in the next lecture, because if we did that in this one, it will get pretty lengthy. So thank you for watching, and I'll see you in the next one. Hello and welcome back. So in this lecture we will be continuing our game development. Last time we made these 3 invaders, and we gave them components such as rigid body, box glider, and the enemy controller script that we will now modify in order to enable them to be alive in our scene. Let's go ahead and open up. I'm just going to close League of Legends here, play the game earlier. I'm just going to close it now. Let's open up this script here, and let's go ahead and create a method for movement. And let's in the update method now call movement, since we will be going to be moving each frame, and each frame we want to be executing the code from this method that will be going to place now. So how Space Invaders usually work is they come up from the top and they go to the bottom, and then they have patterns of movement to maybe they move to the left or to the right. So now if you notice in my inspector, to the right the up and down is the y-axis and the left and right is the x-axis. So we need to get some movement going on those axes. So let's go ahead and open up our script. And in here I can say, well, first we need to get a reference to the rigid body. Let's go ahead and say rigid body, call this variable maybe rig, and when the game starts we can say we grab the component. Oops. So rig equals get component rigid body basically grabs the rigid body of the game object, which allows us to reference each one of these values here and much more. So now in movement I can say rig equals actually rig.velocity, since we want to give it some kind of velocity, equals, and we can say vector3.up times, and since we're moving down we have to say negative speed. Okay, and now this should work if I give him some kind of speed value of 5, and if I drop this invader into the scene, he should move downwards. And he in fact does move downwards. But we don't want him to move downwards, we want him to move down and to the left. So let's go ahead and instead of doing this, we don't want to use one vector. This vector3.up is only referring to let me just grab the player, the up movement, the up vector. But we don't want that, we actually want 2 vectors, the right and the up. So instead of doing this, let's go ahead and say new vector, vector3, and open up the curly brackets. And the first value here is going to be x. So for x, we're going to say speed times time dot delta time, and then we get the y, which is minus speed times time dot delta time, and for the z, just leave it at 0. So now if I save this and go back into Unity, if I drop in my invader and move him like this, it does in fact move downwards, but very slow, diagonally, but very slowly, because we did multiply by time dot delta time, and we should increase our speed. So let's say 50. Let's try that. Okay, still slow. Let's say 80. Okay, maybe 120. Okay, I guess around 150 will be fine. But we don't want him to move in diagonally in one direction. We want him to be switching up directions. So let's go ahead and back in our script, let's create a boolean called direction switch. I'll call it direction switch. And basically a boolean can only be a 0 or a 1. And how we're going to do this is basically when this is a 0, we're going to move him to the right, and when it's a 1, we're going to move him to the left. So if it's true, if it's false, move to the 0, if it's 1, move to the right. And in the start method, let's set that direction switch to be equal to false. And in here, in the movement method, I'm going to say if direction switch is true, move him like this, else now we're wanting to move him on the left, so it's negative speed times time dot delta time, and again negative speed times time dot delta time, and 0 for the z axis. Okay, so now we have our movement, but now if the game starts, direction switch is set to false and we never reset it. So let's go ahead and make use of this change timer value that we have here. We can make a new method called maybe I'm not so creative, let's say switch timer, sure, whatever. And basically what I want to do is each frame I want to say change timer minus equal time dot delta time, and if change timer is less than 0, I want to change the value of direction switch. Basically, if direction switch is true, set it to false, else set it to true. And also we want to reset our change timer. But how do we know what was the first value of change timer? Since each frame now it is reduced, we don't know what was the original value. So to get the original value, we need to create a new, let's call it float max timer. And when the game starts, let's go ahead and say max timer is equal to change timer. And now when change timer is less than 0 and we want to reset it, we simply say change timer is equal to max timer. Okay, so let's save this and head back into Unity. And here our invader is placed, and I can drag him up and run this. So you can see the change timer is 1, so every second he should change directions, but I forgot to call the switch timer method in the update method, so sorry about that. Let's say switch timer. There we go. And let's go ahead and now run the game. Should see him walking left and then he's walking right. There we go. He has a pattern, and we can of course increase the change timer speed here. Now that this will result in a different movement. So he's going for, you can see the timer here decreasing slowly. And the good thing here is we can take these different invaders and just give them different speed values and different change timers, and now they instantly work. You don't have to do any code setup. because they're basically the same. Now in the next lecture we're going to be polishing things up. We will give them health, and we'll make sure that they start at different they start walking in different directions. So thank you for watching, and I'll see you in the next lecture. Hello and welcome back. So last time we modified our enemy controller to enable our enemies to walk around in the scene, but currently they all start in the same way. That's because we set the direction switch to be false by default, and they will all start going to the left, and then they will go to the right once direction switch has been restarted. This is really easy to fix. Basically we can simply say that this direction switch boolean is a public boolean, and then when the game starts we don't want to set it to false, so let's remove that line. And now if I save this and back into Unity, you can now see that my Invaders enemy controller script has this direction switch toggle here. And basically I can, by default it's set to false, but I can set it to true, and now you'll see that this pink one will start going to the right, and as you just saw, he does walk to the right. Also, now we need to give our enemies some kind of health so we can actually kill them with our bullets. So let's go ahead back to our enemy controller, and let's get a public int called health or HP, hit points, whatever you want. I'll call it hit points. And we need to make sure that our friendly bullet is tagged friendly bullet, okay, and it is okay. It doesn't have to be a trigger, but actually we can set it as a trigger. Let's set the friendly bullet to is trigger, and now let's go back to our enemy controller, and I'm just going to drop down the update the movement and the switch timer method since we won't be needing them now. And I'm going to create a method to check for collision. So let's go ahead and say void on trigger enter collider, and now you can name this however you like. I like to say call as in collider, and basically this variable here holds all the information of the game object that we're colliding with. And now we want to check if that game object is in fact the friendly bullet. So let's say if collision.gameObject.tag is equal to, and let me just make sure that I get this right, so it's friendly bullet. I'm just going to copy this name since the name and the tag are the same in this case. So basically if the game object that we're colliding is the friendly bullet, we want to open up curly brackets and then do some code here. What I want to do when the bullet hits me is, first thing, hit points, decrease them by 1, so the enemy ship takes 1 damage, okay. But also we want to create a particle effect, so let's go ahead and get a public game object particle effect. So now our invaders will have a particle effect here, and let me just get the friendly particle effect in here, okay. And I'm just going to instantiate it once it hits me. Instantiate particle effect at the location transform the position, and with your rotation transform dot rotate. Whoops, rotation. Hello. Okay. So now we decrease the health, and if our hit points are less than or equal to 0, we want to destroy. And the game object that we want to destroy is this game object. So let's go ahead and say game object. And also we want to destroy the bullet that hit us, because we don't want it to destroy the ship and pass through it. That's kind of overpowered. So before we create the particle effect, let's go ahead and again say destroy, but instead of saying game object, we're going to say collision.gameObject, which is referring to the game object that we are currently colliding with, which is going to be the friendly bullet. Okay, so let's save this. And now we can go back, and you can see our invaders now have a health hit points here. We can set this to maybe 2 for the purple one, let's say 3 for the green one, and 5 for the third one. And let's go ahead and check out if this works. Yes, it does. You can see I can hit him. Let me just set his speed to 0 so he doesn't move, so you can see that it's working properly. You can see it hits him, and again, and he explodes. Okay. It also works on of course, on all invaders, except this one has more health. And also you can see he collided with us, and he just stopped. He didn't take damage, and we as well didn't take damage. So let's go ahead and fix that. We don't want him to just collide with us without anything happening. Select our player character and tag him as player. And let's go ahead in here and say, let's select our invaders and make sure that the box collider is a trigger, so they can't pass through each other. That's okay. And let's go ahead and say if the game object that we're colliding with is player. Now let me check if our player has health. He doesn't have health yet, so let's go ahead and create a public int HP hit points. So now we want to decrease the hit points of our player. So let's go ahead and say collision.gameObject.getComponent. We need to get the player character script, that component from our player. And now that we have that component, we want to get the hit points integer and decrease it by 1. And we also want our the health of the ship to decrease by 1. You don't have to do this, but I always found it unfair when I hit an enemy, I get damaged, he doesn't. So in my games, I usually make sure that we both get damaged. It's kind of fair. Okay, now we have health. Now we decrease our health, and let's just check if our health is less than or equal to 0, and if it is, we destroy ourselves. Now we won't be also let's create that particle, why not? Also, we won't be destroying the player in this script. We will be destroying him in his script. He will have a check for health. We didn't implement that previously, but let's go ahead and do that now. So now he has health, and we can basically do it, let's say in the well, we can do it in the update method. We can just say if HP is less than or equal to 0, we can just destroy game object. We can make this prettier later, but for now this should work pretty fine. Let's go ahead and check our game. So now if I run, and if oops, I died because my health is 0. I forgot to change the variable here, so let's go ahead and set it to 1. So one hit of these guys is going to kill me, and it does. It killed me, and it decreased the health of Invader 2. You can see his health is now 2, and if I stop playing, it's 3. So that's working perfectly. Okay, so that's going to be it for this lecture. Next time we will be creating a random spawning for these enemies. Thank you for watching, and I'll see you then. Hello and welcome back. So now, if you've noticed, these ships can walk out of the screen, but the player can't. So we gotta fix that. We have to make sure that they can't leave the boundaries. So let's go ahead and open the enemy controller script, and we can do the same thing we did with the player character, where we got a reference to the map limits class as limits, and then we just constrained his position to those limits. So let's go ahead and copy this code here from the player character, and we can just paste it into the enemy controller script in the update method here. But now it won't work. That's because we need to get a reference to map limits and make sure to call this variable the same as we called it here, or else it won't work. And now our invaders will have these limits here. And let's just go ahead and copy the limits from the player. They're basically the same. Let me just see. It's minus 18, 18 minus 10, and 10. So let's go ahead and minus 18, 18. I'm going to, so y for the player is 10 and minus 10 up there, but I'm not going to set it minus 10 for them because they might spawn further up. So let's set this to minus 20 and maximum y to 20. And let me just, can I copy the limits? I can't, no problem. And minus 20, 20. Minus 18. Okay. That should be fine now. And if I go ahead and increase the speed of one of the invaders here, we can see that they in fact do stop at the boundaries. But they still continue moving downwards or down when they stop. They are still game objects in the game, but we can't kill them. So let's go ahead and on the prefabs here add a component. Let's add the def timer that we made. And let's just set the timer to these guys to be 5. I'm going to leave the particle out of here. And let's add the def timer to all of those guys. Let's set it to me. Actually, let's set it, 5 is good enough. So 5 seconds for them to be alive. And now if I run this, and when they walk out of the screen, you can see that after 5 seconds, they will be dead. So that's great. Okay, let's now create a game object that is going to be spawning these guys. So let's create a new empty, and I'm just going to reset the position of this object. And it's just going to be a sorry, there's going to be an invisible game object that's going to be spawning these enemies on set coordinates. So let's go ahead and in our scripts folder create a new C# script, call it game controller. Let's open it up now. Okay. Reload all. And let's also here get the reference to map limits and call it again limits. And now if I put the script, the game controller on the, let's call the game object also game controller game object. Let me just reload the script here. Okay. Now we again have limits, and I'm going to set the minimum x to maybe minus 15 and the maximum to 15, and the minimum y minus 20 and maximum minus 90, because I will be spawning enemies on these positions. And also now we need to reference the enemies that we want to spawn. So let's open this script and let's get a public game object. Whoops, game object enemy1, public game object enemy2, public game object enemy3. Okay, we can now fill these up with our prefabs. So let's drop our invaders here in these slots, and now I can basically say in void start, I can say instantiate, and I want to instantiate the enemy1 game object, and the transform position that I wanted to instantiate, it's going to be a new vector tree, and for the x of the vector tree I'm going to say limits dot x. Actually I'm going to say random dot range, so I'm going to get a random range from limits dot x dot minimum x to limits dot maximum x. So our x value is going to be a random value of the minimum limits minimum x and limits maximum x. And then for our y, I'm also going to say random.range, but this time we will say limits.minimum y and limits.maximum y. Okay, and for the z, just set it to 0. Okay, we are missing 0, and here we need the rotation, so transform.rotation. So this is a big line of code. Let me zoom out so you can see it. I'm just going to segment it into different lines. So instantiate first line the object that we want to create, then the second line is going to be the position at which we want to spawn. So basically a new vector tree, so a new x, y, and z coordinate. And for the x, we get a random range from the limits minimum x to limits maximum x, which is in our case going to be, let me just show you here, -15 and 15. Then we get a random number for y, which ranges from minimum y to maximum y, which is in our case -20 or -19. And then we set z to be 0, and then we set the transform.rotation to be the same as the game object. So let's go ahead and let me just remove these from the scene. And now if I run the game, you can see we got a invader clone here, and he's moving really slowly and he got destroyed. That's because we spawned the prefab, and the speed here is set to really slow, so let's just set it to 500 and set the change timer to maybe 4, and let's enable health switch. Now if we enable this, we can see the invader clone did spawn, but he's walking in a weird path. That's because we got the rotation from this game object. We need to get the rotation from the enemy 1 game object. Okay, so he spawned under for some reason. I think we just missed our y position. Let me just see if I drag the player up. Oh, y needs to be positive instead of negative. Sorry about that, that's my mistake. Okay, save that and let's run the game now. And you can see now our guy just spawned and is attacking us. But this way, only when the game starts, we only spawn one enemy, and nothing happens anymore. Well, we just set things up, and in the next lecture we will build upon this script, so we make it that it spawns multiple enemies and it has a different timer for different enemies. You'll see. Thank you for watching, and we'll continue in the next lecture. Hello and welcome back. So last time we spawned a random invader, but now when he walks to the right, he just hits the boundary and continues going downwards. This looks pretty bad in my opinion. If I now pause this, you will see that he is on the position 18 on -x, which means he's hitting the limit, the right limit of the map, and the left limit of the map is 18, so he would be hitting that if he was on the left side, and it kind of feels off to just hit the wall and continue moving downwards. So I'm going to modify his script to make sure we don't do that. Let's go ahead and open his enemy controller, and now I'm going to create a, you see here how on the switch timer, when the change timer was less than 0, we basically checked if direction switch is true. If it was, we would set it to false, and if it was false, we would set it to true. So let's go ahead and actually create a method that's going to be doing all of this. And you see how we usually create a void method? That means that it isn't returning anything, but this time we will create a bool, which means it will return a boolean. And let's call this method switch direction. Actually, let's just switch there for short. And Now this is underlined because we need to pass in a variable here. So let's call it, we of course need a boolean, and let's call it direction. And it's still underlined because we haven't returned a boolean. If any method isn't a boolean, it isn't a void, it requires a value to be returned. So let's go ahead and say if direction is true, then we're going to set direction switch to be false. Else we're going to set it, to true. And now that we've done that, we can just say return, not renderer, return direction switch. There we go. Now this basically does what this did, but it's a bit more readable, and we can call it whenever we feel like. So let's go ahead and replace this in the switch timer with switch direction. And of course we need now to pass in the boolean, which is direction switch in our case. So now how this script works is when the change timer is less than 0, we will call switch direction and we pass in the direction switch variable, which can either be true or false at this point. Well, let's say if it's true, then we call this method and we say if direction is true, direction now refers to the previous direction switch. If it's true, we will set it to false, which we do, and then we return direction switch, which means we get the value from this method and just update it. So let's go ahead, now that we've done that, in our update method we need to somehow check if the ship is hitting the boundaries. So let's go ahead, this is really easy, just say if transform.position.x is equal to 18. In my case it's 18 because I've set the boundaries to 18. In your case it might be different. So if his position is 18, you're just going to say switch direction and pass in the current direction. So this method now basically turns this boolean from true to false and from false to true. And now again, if the transform.position.x is equal to minus 18, we want to again call the switch direction. There we go. Let's now run our game, see if it works. And in fact it does. You see he hit the boundary and he changed the direction. Let's see that again. There we go. Works great. So that this has been a quick lecture just to polish up the ship movement. This of course now automatically works for all the enemy ships. Just make sure that if you update the limits, to update it in the script. And a nice way we can be even more precise is, instead of saying numbers like this, we can just say limits dot minimum. Actually this is going to be maximum x, and down here we're going to say limits dot minimum x. There we go. So if our current position x is equal to the maximum position x, we're going to switch direction. Now you'll see that this works exactly as it did previously. There we go. But now the thing is, if I go to my invader and if I set his limits to be maybe, instead of minus 18, minus 15 and 15, you will see how he bounces off sooner. But if you just kept the numbers, you would have to go back to the script and update the numbers, but like this it's always going to be updated the same. Just make sure to update the limits on the prefab. I'm just going to return them to 18, and that's going to be it for this lecture. In the next one we will be creating the random spawning of the enemies, and we will be adding score. So until then, thank you for watching and I'll see you next time. Hello and welcome back. So last time we made the enemy ships change direction when they hit the boundaries, and now I want to modify the game controller so that it spawns multiple enemies. So now in our game controller script you can see that when the game starts we just instantiate a simple enemy at the random position on minimum x and minimum y, minimum x and maximum x, and for y the minimum y and maximum y. Then we just set the z to be 0 so that our player can indeed hit him. And then we just set his rotation to be the game object rotation. So we just need to figure out a way to call this method whenever we feel like it. So let's go ahead and create a method called maybe spawn enemy. And then here, first thing that I'm going to do is, since we have 3 enemies, I'm going to generate a random number from 0 to 2, and depending on what the number is, we're going to spawn that enemy. So let's go ahead and say integer. Let's call it a random number, and this is going to be a random range between 0 and 2. So it could be 0, 1, or 2, which is 3 numbers for the 3 enemies. And then we can create a switch statement for the random number. This needs to be, of course, in brackets. Okay, so switch random number, and let's say in case it is 0, we're going to want to, let's first, of course, break this case statement. And if it is 0, we're going to just instantiate the first enemy. So let's go ahead and cut this from the start method. Okay, now for case 1, in case the number that we generated is 1, we will want, we'll want to instantiate again an enemy, but this time we're just going to create the second enemy, enemy 2. Okay, and let me just, and finally case 2, we're going to instantiate the third enemy. You can of course play around with the random generation however you wish, maybe add in more parameters. The way this is set up, each enemy has the same chance of being spawned, but some enemies are tougher. For example, the enemy 3 is significantly tougher than enemy 2 and enemy 1. Maybe you would want enemy 1 to have a higher spawn chance. We'll talk about that soon. Let me just get the default case, which is just going to instantiate the enemy 1. And of course we need to break this as well. Okay, now we have our spawn enemy method. We can drop it down. And let's go ahead, when the game starts, call spawn enemy. Oops, spawn enemy. And let's get some kind of timer going. So public float spawn timer. And in update, like we usually do, we're going to make sure that we subtract from the spawn timer each frame, and if it's less than or equal to 0, we're going to call the spawn enemy method. But before we do that, we want to, let's get a float called max spawn timer, and when the game starts, I'm just going to set it to the spawn timer, so that now after we spawn an enemy, we can reset the spawn timer so that we can spawn another enemy. Okay, so now if I go back to Unity, and my game controller will now have a spawn timer, and let's say I set it to 0.4. Now if I run the game, every 0.4 seconds I'm going to get a new enemy, and I'm getting a ton of enemies here spawned. For some reason they're not moving. Let me see what's wrong there. I think they don't have, yeah, the invader tree, these enemies don't have a speed, so let's go ahead and set the speed on their prefab. So the invader one has a speed of 500 and the change timer is 4. So let's set the invader 2 speed to maybe 600 and the change timer to 2. The HP on the first one is 2. Let's set the second one to be 4. And let's set the third invader to be really slow but have a lot of health, like 5, and set the change timer to maybe, I don't know, 4. Okay, now if I run the game, you can see that we're getting a lot of these enemies. They're spawning randomly, and there's a lot of them coming in. Of course, you can increase the spawn timer, maybe 0.8. Now we will have less enemies, you see, much less than previously. And also I would like to just increase the size of the camera. Okay. So that we can see more of the... But now we will have to increase the boundaries, which isn't too big of a deal. Let's now go back to our script. And you can see here how we had these... How we generated a random number between 0 and 2 and then checked if it's 0, 1 or 2. Well, we can now generate, let's say, from 0 to 100. And we can say in case that random number is less than, let's say, 40. Oops. Interesting. Well, never mind, let's just leave it like this. And let's go ahead and see what our current boundaries are. So let's move the player to the right. So let's say 26, and I guess minus 26, of course. Let's just set that to 26 and minus 26. And of course set the prefabs of our invaders, set their limits to be as well minus 26 and 26 on the X. There we go. Now I can run the game. And we're getting these enemies, they're spawning. And they're running around. So soon we'll be... and I got killed. Now we will be, in the next lecture, implementing a score, and I also want some of these enemies to shoot. And so it's a greater challenge. And we'll do that next time. Until then, thank you for watching, and goodbye. Hello and welcome back. So in this lecture, what I want to do is I want to enable some of these enemies to shoot. So let's go ahead and take this invader tree, and I want to make sure that he can shoot us. First off, I don't want it to be rotated like that. Oops. Let me just wait a second. No, just a moment. Yep, yes, that's what I wanted. Something like that. Let me just go ahead and check him out in the scene. There we go. That is good enough. And of course, as we did with the player, we want to specify a position from which he will shoot. So let's go ahead and right click on him and create a 3D cube. Now let's just move it down here. Make sure that it is under his, like this, where you want to shoot from. I want him to shoot from this position. And I'm going to rename this cube to shooting position. And I will also disable the box collider and the mesh renderer, because I don't want this to be visible. Okay. Now let's go ahead and open the enemy controller script. And first thing what I want to do is I'll go ahead and create a public boolean, which is just going to be it's going to be called can shoot. Okay, so basically, since all enemies have this component, but I don't want all of them to be able to shoot, I made this can shoot variable, and invader 1 will not be able to shoot, invader 2 will not be able to shoot, but invader 3 will be able to shoot, so let's set that to true. Okay, and of course we need to get a reference to the shooting position, so let's say public transform shooting position. And when the game starts, what I want to do is check if he can shoot. If this is the case, go ahead and just set shooting position to be equal to, wait a second. Let's just drag this in here. Okay, like that. And let's go ahead and we need some kind of random value to determine when this guy is going to shoot. And of course we need the game object that we're going to be shooting. Game object is going to be called just a bullet. Let's save that. And back here I have my, I believe we have the enemy bullet model here somewhere. Here it is. Just drop the PNG on him. Okay. Of course we need to resize it, it's too big. And let's just add a box collider to this object. Actually, you know what, let's just use the, let's just get the player bullet, the friendly bullet, drop it in here, rename it to enemy bullet, and change the tag. Add a tag. We will add the enemy bullet tag. Add it here. And now we can click on the default. When we drop down the enemy bullet, we have the default of this model, which is the shader and the color. So let's change the color to something different, like bluish, like that. Maybe bump up the smoothness. Okay. And let's create a prefab from the enemy bullet. Now that we have the prefab, let's go to the invader tree and drop our enemy bullet in there. Make sure to apply this change on this object so that the changes also apply to the prefab. Apply. And now let's go ahead and figure out how we actually want this guy to shoot. So we want some kind of timer that when the time passes, we want him to shoot. So let's go ahead and say public float shoot timer. Actually, let's just make this a private shoot timer. And I'll just set it to maybe 1 second. And in our update method, we'll say that shoot timer minus equal time the delta time. Oops. And if the shoot timer is less than or equal to 0, of course, what we usually do, first off, let's get a max shoot timer. And now, actually, well, yeah, sure, let's do it like this. You can make shoot timer public if you want to have different shoot timers, or you could get a random number. Actually, let's go ahead and do that. Instead of shoot timer being 1 second, let's go ahead and say that it's a random range between 0 and, let's say, 4 seconds. And then we set the max shoot timer to be equal to shoot timer. And here, if shoot timer is less than or equal to 0, we're going to first off instantiate the bullet, add the transform.position with the transform.rotation. But we need to make sure that this is a new game object, so let's call it new bullet. Okay, and now that we have the new bullet, let's go ahead and actually get the rigid body component. Okay, and now set the velocity to be equal to vector 3.up times negative, let's get some kind of speed value here. Negative speed. Actually, let's get a new, call it public float shoot power. So times shoot power, there we go. Okay, and of course we need to reset the shot timer, so let's go ahead and say shoot timer is equal to max shoot timer. Save that, and let's go ahead and now back on our invader. We have the bullet, everything is set up properly. Let's just apply this, and now if I just set the speed to be 0 so he doesn't move, I want to see if he's going to be able to shoot us. Let's see. Now you see he's colliding with his own bullet there. Let's just see the... We need to fix that. We also need to add the shoot speed. I forgot that. Shoot power. Let's set it to maybe 50. And enemy bullet is trigger. Okay. And let's make sure that on trigger enter, if the collision.game object tag is equal to enemy bullet, I want this just to return so nothing happens. Let's check it out now. He's still colliding with himself. Enemy bullet. It's tagged enemy bullet. It is a... Okay. Oh, we need to spawn it at... Wait a second. At the shoot position. Shoot position dot transform dot position. And he's still colliding with himself for some reason. And we might have to just make sure that he will ignore the collisions. So let's set the layer to be... Let's add a enemy layer to him. Set the layer to be enemy. Yes, change the children. And apply this. And also apply the enemy bullet. Set the layer to be enemy. Yes. You can see he is shooting them, but it's really slow and they die after a few moments. So let's increase the shoot power to maybe 500. And what happened now is, let's select on invader. Our shoot timer, let's set the range to be from 1 to 5. F and make sure that... Okay, let's go ahead and play it now. Let's set the shoot power to 5000. It's still pretty slow. What's happening? Interesting. Oh, we have to reset the shoot timer, not the shoot power. Sorry, that's a mistake there. Now the bullet's going to be super fast. Oops, it was too fast for us to even see. Set it to 50. Also, we're getting some kind of errors. That's because that we're doing this all the time, even if the even the Invaders 1 and 2 are doing this, but they shouldn't be doing this because can shoot is false for them. So let's go ahead and make sure that we do that. So let's say if can shoot is true, we're going to be checking this. If it isn't, we're not. So let's just run it now. You see he shot the bullet, but it was super fast, and now we didn't get the error messages. So let's set the shoot power to maybe 5. Actually, let's check the shoot power on the player. What is his shoot power? 50. But we multiply with time the delta time there, so okay, there we go. But that's also pretty slow, so let's set it to maybe 10. whoops, not the HP, we want to set the shoot power to 10 and the speed to 200. And let's now apply this invader and just delete the game object here. And now if we run our game, we will be able to get these enemies, they're spawning, and the invader tree will sometimes shoot bullets. We're not seeing them currently because their color is similar to the background color, so I'm just going to go ahead and set the main camera color to something more bright. Okay, let's get that color. Alright, let's run the game again. Oh, this color isn't anything better, but our game is working. We're not getting any invader trees for some reason. Is it possible that the chances of spawning them is super slow? Or did we mess something up? We didn't, I guess. It's just a small chance. Or actually, let's see. No, everything is set up properly. I'm just waiting to see if it's going to be generated. We're getting the 1, 2, 1, 2, 1, 2. Where is the third one? Is interesting. Maybe random range 0 and 2 aren't included here, so let's say 0 and 3. I think that was the problem. 2, 3, yeah, now we get the third one, and you can see he's moving slower. Okay, so that's been it for this lecture. In the next one we'll add scores and high scores, and we'll also implement the power-ups so they work. Thank you for watching, and I'll see you in the next lecture. Hello and welcome back. So today we'll be implementing a high score and also the power up and power down drops. Let's go ahead and add a UI canvas text. Now we got this text here, and let's make sure that we select the canvas and go to render mode to be, the UI scale mode to be scale with screen size. That way, even if you have different resolution, it will always be the same. And let's position this text in the left corner. You can click on this anchor presets and hold down Alt to instantly move the text to a different position. Usually the score is in the top left. Now let's just increase the width and height to maybe 250. And let's set the position on the Y to maybe minus 25 and the position on the X to 120. Now I'm going to increase the font size to 18 and just call this score. Whoops. Score. Maybe also set the color to be white. And then I'm going to duplicate it and call this text score and set the value of this to be 0. And I'm just going to move it to maybe position 150. Actually, let's say 200. That's too much. So 180. 90. Okay. So that's our numbers. And this will be our score. When the player kills an enemy, he'll get some score. By default, it's of course 0. Now let's open up our player script and go to the player character. Now let's create a public int score, and let's get a integer called high score here. And basically whenever we kill an enemy, let's go ahead and just see something. Whenever we kill an enemy, I want to give the player some score. But let's just say that we also need the reference to the score text. So let's say public text. And since we're working with Unity UI, we need to implement the libraries for Unity UI. So let's say using Unity engine.ui. And now I'm going to get a public text and I call it score text. And basically in my update method, I'll make sure that score text.text is equal to score to string. So each frame I will be updating my score, and score text.text, as we spoke about previously in the canvas, will just set the text of the score to be equal to our current score, just transferring from integer to string. Now let's go ahead and open up the enemy controller script. And let's find the script here. When the bullet kills the enemy, we want to give the player some score. But we don't know how much score we want to give him. So let's go ahead and create a public integer score reward, so that each one of these enemies has a unique score reward when you kill him. Some might drop you 2, some might drop you 5, and others might drop you 10 score. Let's go ahead and scroll down on the onTrigger enter method, and right before we destroy the enemies, we want to let's create a new method called void destroy self. And what I want this to do is basically let's not do it like this. There's no need. So if the health is less than or equal to 0, we want to destroy the game object. But first, before we do that, we want to give the player some score. So let's go ahead and say collision.gameObject, and let's get the component. We want to get the player character script, because that script holds our score, and we want to say score plus equals score reward. So we will increase the player's score when we kill an enemy by the amount of score reward specified by us. And let's also copy this. Let's copy this, all of this code, and replace it with this here. So now when the bullet kills this enemy, and if its health is less than or equal to 0, we will get the player character component from the player character. Actually, you see, now this wouldn't work, because here we're checking if the collision game object is the bullet. So if we're colliding with the bullet, sorry about that. And if we are, what we're going to do is we destroy the bullet, and then we create the particle, then we subtract health, and if the health is less than or equal to 0, and here we try to get the player character component from the collision game object, but we can't do that because the bullet doesn't have the player character component. So we can do it like this. Let's delete this and go ahead and say game object, find game object, find game object with tag, and the tag is player, and we want to get component player character, and we want to increase the score by the score reward. There we go. So if our HP is less than or equal to 0 by a bullet collision, we're going to find the game object with tag player and get the script. Then we will increase the score. So let's save this. Make sure that the player character has the tag player here, and now go to our invaders. And you can see now that we have the score reward here. I will set this, so the first one I want him to give me 5 points, the second one will give me 10, and the third one will give me 15. Also, we need to click on our player character and make sure that our score text is indeed connected to the score. Now if I run this, you will see as I'm killing these enemies, I'm getting more score. There we go. Now let's create a high score. Now let's move back to the player character, and I believe we spoke about player preferences, but if we didn't, basically we just create a file with some kind of name and we plug in some kind of value to that preference. So let's say that, let's go ahead and say if score is greater than high score, Oh, just a moment, please. If score is greater than high score, what we want to do is player preferences, set integer, set int, and we want to call this integer high score, and we want to set its value to be equal to high score. But before we do that, we want to set high score to be equal to score. And now if the score is greater than the high score, we will set the high score to be equal to the score, and then set the player preferences to be the high score. But when you first start off the game, you don't have a high score. So let's just, when the start method goes, I'm going to check if player prefs has key. This means if the high score has been created. So if this is false, I'm going to set the high score. I'm going to set high score to be equal to 0, and then I'm going to create it by saying player prefs.set int high score Let me just copy this. I had a typo there. There we go. So now when the game starts, if this wasn't created, we're going to set the high score to 0 and then create it. And when our score is greater than the high score, we will set the high score to be equal to score and then save that as well. So in the next lecture, we will be adding the power-ups and power-downs, and we'll also display the high score when we die. Until then, goodbye and see you next time. Hello and welcome back. So last time we made a score and we added high score logic, but we didn't really add a high score. So let's go ahead and copy the score, just duplicate it, and I will call it high score. And let's just reposition it to maybe the bottom right and make sure that it is centered and okay here. Okay, should look fine. And now back in our script, when we update our score, let's go ahead and update our high score as well. We also need to get a reference to the high score, of course. So public text high score, and whoops, it's the same as the integer. So let's go ahead and avoid that. High score text, let's call it that, and make sure that after we update the score, we update the high score as well. So let's go ahead and get the, here we want this to be equal to the player preferences get integer. So we want to get the high score from our preferences and make sure that it is converted to a string, and then we are going to be adding it to the text. Let's see if that works. I'm going to, whoops, just add the high score to the player. Okay, there we go. High score text, there you are. Now if I run, you can see how the high score is updating as well, and now I've died. If I restart, it should be set to 15, and there you are, the high score is 15 and the score is 0. Of course, you can polish this up a bit by adding, you know, text and more beautiful colors, but I don't want to take up your time with that. You know how to do that by now. Now let's go ahead and go to the enemy controller, and what I want to do is get a public game object and actually, yeah, game object power up and a public game object power down. Now I want these to be spawned when the character, when the enemy is killed. So let's go ahead and when we die here, before we die, I'm actually going to create a random number. So int random number. I'm going to go ahead and say random.range between 0 and 100. And if this random number is less than, let's say, 50, actually if it's less than 30, I'm going to instantiate the power up at transform.position with power up dot transform.rotation. But if the random number is greater than 80, I'm going to instantiate the power down at transform.position with power down Transform.rotation. There we go. Make sure to copy this for the bottom code as well, because this is when the... Actually, let's not create the power-ups when the player kills us, because it might be unfair when we collide with the player. We just create a power-up and we kill him. He doesn't have time to react. Now back into Unity. If we click on our invaders, we need to give this to all of them. So let's go ahead and select the first one, the prefab of course, and now we have the power up and power down parameters. Make sure to just add our power up and our power down, and of course to the second one and to the third one. There we go. Let's just check if our power-ups, let's add to our power-ups the death timer script. I want them to be destroyed after 3 seconds. And there we go. Now if I run the game, we have a high score and we have power-ups. Let's see if I can actually get to the point where we get some power-ups. Okay, there's one power-up. Now we're much stronger. There's another power-up, there's a power down. And after some time they of course disappear. Okay, so this looks awesome. The high score works, enemies work properly. So yeah, that's been our Space Invaders game. In the next section we'll go ahead and enter the world of 3D lighting, shaders and things like that. But for this game I want you to polish it up a bit, make the background more beautiful, and add some more special effects. Create particle effects for all enemies, so when each enemy dies, create a particle effect for him, and send us your version of the game, build it, and send us an executable. We would love to play it. So thank you for watching this section, I hope you enjoyed it, and I'll see you in the next one.